Hi everyone, I'm Santhi Priya from Department of Mathematics and Statistics, Bhavan Vivekananda College. I'm here with a lesson to explain basic ordinary differentiation without learning the actual geometrical or definition of differentiation, but to start with working out small problems, simple problems of differentiation, just using the formulae, which is helpful for those students who are coming from the non-mathematical background. Let us learn ordinary differentiation. Let y is equal to f of x be a function. So you would have learned in your earlier classes, when a function is given, it can be put in the form of y is equal to f of x. In this we call x as independent variable and y as dependent variable. X is independent variable, y is dependent variable, y is a function of x. So let us understand it graphically also. If you take a two-dimensional plane with x-axis and y-axis, and then x is taken, the independent variable is taken on the x-axis and the dependent variable y is taken on the y-axis. So suppose the y is equal to f of x function is giving you a graph like this, a curve like this in two-dimensional plane. Then here you can observe that as you give the input x, suppose I have given x some value, correspondingly you will have this is y value on the curve. So suppose this, if this is x I have given 2, y may be some value, suppose 3. That means, what do we mean by that? As you give the x input, which is independent variable, y will be changing according to x. So if I give suppose x as suppose it is, I have given here 3.8. So correspondingly y value may be, here we don't know what is the defined function, it may take some value. I can just assume that it may be some 5.2, some value. It's not exact, just I'm giving as an example. So here we can understand what do we mean by independent variable and dependent variable. The input what we are giving for x is independent. We will give whatever the value which is on the x-axis. We may take any values. Then the output, the result defined by the function y is equal to f of x will give you y. So y is called as the dependent variable. Now quickly let us understand what is dy by dx or d by dx of y. We call this as a derivative of y, d by dx of y. So why we are calling it as like that? The function we have understood that it is in the form of y is equal to f of x. That is, as y is a function of x, so dy by dx means differentiating y with respect to x. Why it is with respect to x? Because the function y is in terms of x. Therefore, we will differentiate y with respect to x, that we call it as dy by dx. Dy by dx, or you can say that it is d by dx of derivative with respect to x of what function? Y, or y is nothing but f of x. So that is what we mean by dy by dx, d by dx of y, differentiating y with respect to x. Here you can understand. Suppose I have a function u is equal to f of x. For example, I have a function u is equal to 2t plus t square. So what is it? U is a function of x. If I write it as y is equal to x square minus sin x, here I call it as y is a function of x. If I write u is equal to 2t plus t square, what do I mean by that? U is a function of t. So here variables don't matter, whatever the variables we take. But what is the independent variable, what is the dependent variable, that we have to identify from the given function. So let us, if it is u is equal to f of t, then what do we mean by here? U is a function of t. U is in terms of t, then derivative of u with respect to t. We will differentiate the function u with respect to what variable? Not with respect to x, because the function u is a function of t. Therefore, we have to differentiate u with respect to t. Then we write it as du by dt. that is d by dt of u, or you can say d by dt of f of t. So we can say here differentiation, when you are doing ordinary differentiation, then you have an independent variable, a dependent variable, and you will differentiate a dependent variable with respect to the independent variable. That's what we mean by whether dy by dx or dy by dt. Now even you can note down the point, dy by dx is also written as y dash, the derivative, first derivative also. Now let us go for the formula set, and we will see how do we solve the problems, basic problems of differentiation using this basic formula. So the first one is derivative of a constant. So if a function is a constant, what are constants? Numerical values, 5, 10, minus 10, 100, any numerical values. Then we say that derivative d by dx of c is equal to 0, where c is any constant. That is, for example, if I have y is equal to 5, this is a function given to me. Then what is d by dx of 5? 5, as 5 is a constant, it is 0. That is the first formula. Similarly, you can say d by dx of 10 is 0. D by dt of 15 is equal to 0. Whatever may be the variable. Here it is function. It's a constant. D by dt of 15 is equal to 0, or you can say d by dx of minus 50 is equal to 0. So you can remember that derivative of a constant is always 0. Then what is the second important, the basic important formula in ordinary differentiation? D by dx of x power n, which is a polynomial function. Here we call this x power n. It is a polynomial function. You would have learned polynomials in school. X square, x minus 3, x square minus 5x plus 4, all these are polynomial functions. So if it is in the form of x power n, then d by dx of x power n is n into x to the power of n minus 1. This is a formula you have to remember. So d by dx of x power n is n into x power n minus 1. What is n here? N is any numerical value, or you can say constant. So let us see by examples. What is d by dx of x square? So here what is n? N is equal to 2. So according to the formula, n into x power n minus 1. So 2 into x to the power of 2 minus 1. So it is 2 into x power 1, which is nothing but 2x. So similarly, let me take next one, d by dx of x power minus 5. So what is in here? Minus 5. So it is minus 5 into x to the power of minus 5 minus 1, which is equal to minus 5 x to the power of minus 6, minus 5 minus 1. Similarly, if I say d by dx of x, x is also a polynomial. So what is the x power here? X power is 1. So what is it? 1 into x power 1 minus 1. That is equal to 1 into x power 0 is 1. So in general, we remember it as a formula that d by dx of x is 1. So it is not only for x, we can do for any functions. It's not just with respect to x. Suppose I have d by du of u to the power of 2 by 3. So here what is the independent variable u here? So what is the formula? Like x power n, you imagine it as u power n. Then what is the derivative formula? N into u to the power of n minus 1. So n is here 2 by 3. So 2 by 3 into u to the power of 2 by 3 minus 1. So which is equal to 2 by 3 into u to the power of 2 minus 3 by 3. So 2 by 3 into u to the power of minus 1 by 3. Similarly, I take another one, d by dt of t power minus 1 by 5. Now I have taken a function which is a function of t. So which is equal to, what is n here? So again, just imagine, observe this as t power n. The formula, take it as t power n. What is the formula for derivative? N into t power n minus 1. So if you apply that, n is minus 1 by 5. So minus 1 by 5 into t to the power of minus 1 by 5 minus 1. That is minus 1 by 5 into t to the power of, take LCM, minus 1 minus 5 by 5 minus 6 by 5. Hope you understand what do we mean by d by derivative of x power n formula. So we have till now we have learned mainly 3 formulae to remember. That is, the first one is derivative d by dx of x constant, sorry, d by dx of constant is 0, and the second one is d by dx of polynomial function x bar n into x bar n minus 1. It's a formula. Then d by dx of x, which you can, even 3 is included already in the formula 2, but still you can remember it as d by dx of x is 1. Even you can say d by dt of t is 1. Okay. Or you can say d by du of u is equal to 1. So you are differentiating u with respect to u. That's why you are getting it as 1. I hope it is clear till here. Now let us move for the next one. Formula set 2. What is that formula set 2? It's just to remember as formula. D by dx of e power x is e power x itself. And d by dx of log x is 1 by x when x is greater than 0. So here you call e power x as exponential function and the log x as logarithmic function. So similarly you can say with respect to t, the same thing you can see. D by dt of e power t means e power t itself, just a formula, and d by du of e power u is e power u itself, and you can say d by dt of log t means 1 by t, d by dp of log p is equal to 1 by p. So now let us go for the next formula set, that is for the trigonometric functions. So that is the direct formula, d by derivative of sin x, d by dx of sin x is equal to cos x, and d by dx of cos x is minus sin x, d by dx of tan x is equal to secant square x, and d by dx of cosecant x is equal to minus cosecant x cot x, and d by dx of secant x is equal to secant x tan x, and d by dx of cot x is equal to minus cosecant square x. So these are direct formulae. Whenever you get that term, you will apply the formulae. You have to remember them as formulae. Then what is the formula set 4 about the? It is about inverse trigonometric functions. Inverse trigonometric functions. So you can just go through simply because you will use them as just formulae. D by dx of sine inverse x is 1 by under root of 1 minus x square, and d by dx of cos inverse x, d by dx of tan inverse x, and d by dx of cot inverse x, d by dx of secant inverse x, and so on. Just you have to learn them and use them whenever you get them in a problem. So the same way, even I'm not here mentioning, but you have formulae which will be provided, which can be provided later in the notes. The same way, formulae for hyperbolic functions and inverse hyperbolic functions also you have to note down and you have to use them in while you are doing the differentiation process. Now we'll go for the set 5 formulae. This is for the algebra of differentiation. That means the first one, if you observe. Suppose what do we have? Let me write x. Yeah, d by dx of u plus or minus v. So what are u and v here? U and v are nothing but, like you can say, u comma v are just any functions of x. So d by dx of u plus or minus v. So you can split them and write according to this algebraic sign, that you can write it as d by dx of u plus or minus d by dx of v. So let us see how it is going with the problem. Suppose I have now d by dx of x cube plus log x. Right. So I have two functions, sum of two functions. One is x cube, another one is log x. So according to the above formula, if you have differentiation of sum of two functions, you can do the differentiation function by function and add them. So what do I write here? I'll write this as d by dx of x cube plus d by dx of log x. And we'll use the same formula which we have noted above. What is d by dx of x cube? What formula you will use it for? For x cube, you will use the formula d by dx of x power n is equal to n into x power n minus 1. So here you have d by dx of x cube. So this is 3 into x to the power of 3 minus 1. And d by dx of log x is 1 by x. So its final answer is 3x square plus 1 by x. Right? So let us here one more thing, let us note down. Suppose you have d by dx of c into y. That means where c is a constant here. If I have c a constant, constant. Right. Then what can I do? I can just bring it out c because into d by dx of y. So how that is, let us look at for this example. D by dx of 3x power 4, suppose. Then here x power 4 is a main function. It has a multiple 3. That multiple 3 you can bring it out. 3 into d by dx of x power 4 you can write. When it is in the multiple, not in the addition or subtraction. It is in the multiple, you can bring out that constant. That is what we mean by here d by dx of cy. So this will be 3 into, again for x power 4, what is the formula we'll use? X power n into, we'll use the formula n into x power n minus 1. That formula we'll use it here, sir. Right? So here you have 3 into 4 to the power of x minus 1, right, which will be 12x cube. 12x cube. So I hope you understood. Whenever you have any polynomial function or a trigonometric function which has a multiple scalar constant multiple, that constant can be brought out 3 into d by dx of x power 4. You can do the differentiation only for x power 4 and you can write 3 as a multiple. So let us just quickly go to another example also. Suppose I have d by dx of sin x minus 5 log x. So I will apply, I have two terms which are separated by minus according to our above formula. What is that we have? If I have u plus or minus v. So I can split that and I can write it. So I have written this as d by dx of sin x minus d by dx of 5 log x. So the two functions I have, one is 1 and two functions which are separated with minus. So I am doing differentiation also separately, d by dx of sin x minus d by dx of 5 log x. So which is what is d by dx of sin x? Derivative of sin x is cos x. And then here you see, here this log x is a multiple of 5. So if it is a multiple of 5, you can bring that multiple out. That is 5, you can bring it out. 5 into what is derivative of log x is 1 by x. Derivative of log x is 1 by x. So you have here cos x minus 5 into 1 by x. So this is what, how do we do addition, like addition of two functions? How do we differentiate addition or subtraction of two functions? Now we are going for the very, very important one among the important basic one, that is a product rule. Before I said that when I have d by dx of u plus or minus v, when with addition or subtraction, I can separate du by dx plus or minus dv by dx. But can you do if I have d by dx of, if I have d by dx of, suppose just, yeah, product of two functions. Can I do it as like the same as du by dx into dv by dx? Just how addition or subtraction I have done for each and then added or subtracted. Can we do that even product also? No, we are not supposed to do the product in this way. There is a special formula which we call it as a product rule. So here I have d by dx of u into v, where dot means into product. That is what you have to do, one function u, first function u into d by dx of v, derivative of the second function, plus second function v into derivative of the first function. Or you will write it as uv, product uv dash, that means derivative of the product u into v is equal to first term u into v dash, derivative of the second one, plus v into u dash. This is very, very important, and we keep on using this product rule, quotient rule, every formula, each and every formula we have to be using extensively when you are doing the differentiation. Without formula, you cannot do anything. So let us quickly look at first example, d by dx of x cot x. Right. Now there are two functions. What are the two functions you have here? One is u, another one is v. U is equal to x here and v is equal to cot x. There are two functions, product of two functions. So this is first function, x into, according to formula, x into derivative of the second function. What is the second function? Cot x. So d by dx of cot x plus cot x into d by dx of x. Second function cot x into derivative of the first function. So that is equal to x into, what is cot x derivative is, we have the formula list, which is minus cosecant square x plus cot x into, what is derivative of x? D by dx of x is 1. So which is equal to minus x cosecant square x plus cot x. So let us do one more on the same thing, that is d by dt of t square into sine inverse t. So which is equal to, again u is equal to t square and v is equal to sine inverse t. So t square into d by dt of sine inverse t, first function is t square, second function is sine inverse t. So first function into derivative of the second function sine inverse t plus sine inverse t into derivative of t square, second function derivative, which is equal to t square into, just for formula list you can extract sine inverse t, d by dt of sine inverse t is 1 by under root of 1 minus t square plus sine inverse t derivative is sine inverse t into d by dt of t square is 2t. Derivative of t square t. How did you get this one? T power n is equal to n into t power n minus 1 d by dt of derivative. So t square means 2 into t power 2 minus 1. So 2 into t power 1, which is 2t I have written here. Right? Right. So this will be is equal to t square by, so this simplifying, under root of 1 minus t square plus 2t sine inverse t. We have seen for two terms. Then what do you have to do? You will consider these three terms as two terms, like u first term and v and w as a second term. Then apply the same concept of the product rule. What is that concept of product rule? First term into derivative of the second term. What is the second term here? vw. So vw dash plus second term vw into derivative of the first term, that is u dash. And now expand it, u into this u here into, again derivative of vw dash means inside you have again two terms again. So for that apply product rule again, that is first term v into derivative of ww dash plus w into v dash. So that means for this vw, because you have to apply differentiation derivative, you are doing again product rule for this plus, and this is vw is normal term into derivative of u is u dash. If you expand this, you will get u vw dash plus uwv dash plus vwu dash. So in this sense, to remember it simply, we can observe here there are three terms. Then what do? Just you remember, I can remember, I just want to remember in this way. Product of, like derivative of the product of three terms, uvw is equal to 1 u dash, derivative of the first term into second terms, don't differentiate as it is, plus then u into second, for the second term do the differentiation into w plus first term, second term normally u into v, and the third term differentiate it to w dash. Is it clear? Right. So here next, this is with the product rule. Now let us go for the quotient rule. Quotient rule or division. The same way, like as I said, suppose I have the same thing I said here. If you have u plus or minus v, so you will use du by dx plus or minus du by dv. But for it's the same way you can't apply. If I have d by dx of u by v, I don't say it is just du by dx by dv by dx. This is wrong. I shouldn't do that. Like product, we have even for the division also we have a formula, quotient rule, or you can say it is a division. So d by dx of u by v, where there are two functions u and v which is given as a quotient. Then what is the formula is, the denominator will be v square, v will be v square, then denominator into v into derivative of the numerator du by dx minus numerator u into derivative of the denominator, that is dv by dx. So you can say that u by v dash is equal to v u dash, du by dx is nothing but u dash, minus u into v dash is nothing but dv by dx by v square. So you can remember this as a formula, u by v dash is equal to v u dash minus u v dash by v square, which is very, 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 very important. Now let us quickly look and do one problem using the quotient rule. What is that? D by dt of cos t by t cube. So here what is u for us? U is equal to cos t and v is equal to t cube. So recollect the formula. What is the formula you have? U by v dash is equal to v into u dash minus u into v dash by v square. This is the formula. So denominator first, take the denominator first. What is denominator? T cube into derivative of the numerator d by dt of cos t minus, take the numerator cos t into derivative of the denominator d by dt of t cube by denominator square, t cube whole square. So which is equal to t cube into, what is the derivative of cos t? Minus sin t minus cos t into, now what is the derivative of t cube? Quickly you can use the formula. T cube derivative is 3 into t to the power of 3 minus 1, which is equal to 3t square. So directly I have written it as 3t square by t cube whole square is t power 6. So finally you have minus t cube sin t, t cube into minus sin t will give you minus t cube sin t minus 3t square cos t by t to the power of 6, which is equal to, if you can take t square common, then you have minus t sin t, t square you have taken common from t cube. So minus t sin t minus t square you have taken common, 3 cos t here by t power 6. Cancel t square by t power 6. T square by t power 6. Cancel this 2 and then here 4 remains. So you have minus t sin t minus 3 cos t by t to the power of 4. This is what we mean by quotient rule. Right. Next we are going for the chain rule. The next one is the chain rule. What is that chain rule? Suppose I have a function like this, y is equal to sine log x. See, if I have y is equal to sine x, I call that as a sine function. Or if I have y is equal to log x, I call it as a logarithmic function. If I have y is equal to x square, I call it as a polynomial function, one single function. But if you observe here, y is equal to sine of log x. So here what is happening, y is a function of another function. It is mainly sine function. And again inside that sine function of log function. So here y as a sine function and sine again as a log function. Sine is a log function. So this we call it as a composite function, or y is a function of another function, that we call it as, or you can even call it as a composite function. I will write here composite function. Function of a function. So then how do we differentiate? So we'll write like this. Y is equal to f of u, where this u is not, u is again another function, that is a function of x. Then how do we do this differentiation? Y is a function of u is a function of x. Y is a function of u and u is a function of x. there is no direct relation from y to x, y to u and then u to x. But I want the derivative of y with respect to x when there is no direct relation from y to x. If I have to go from y to x, I have to go to u and then I have to go to x. I have to take break journey. Then what do we do? So suppose I have this one d by dx of function of u. This I want to differentiate. So this, what do I do first? I will differentiate y with respect to u. Right? And then this is not plus. Sorry. And then I will multiply into. Then I will differentiate u again because u is another function with respect to x. So differentiating y first with respect to u and then differentiating u with respect to x. That is what we have to do. So this you will give you dy by du into, and this will give you du by dx. So finally, to reach x from y to x, you have to cross u in between. So it is dy by du into du by dx. This is very, very important to remember. So here let us look at one example. Suppose I have, what is the same thing I have given here? Y is sine log x I have given. So this is y is, this is sine function, yeah, sine u. In the given problem I have it as sine u. Let me just write it clearly. It is sine u. So what, but so here you see y is a function of, sine u, where u is a function of log x. But I want from y to x differentiation. I want a derivative of y with respect to x. Right. So I want to differentiate with respect to x. So I have, what is the derivative of sine? First I have to concentrate on sine. That is cos. So I have dy by du means cos of log x. I have cos of log x into, what is du by dx? Derivative of u. That is derivative of log x. d by dx of log x. So cos of log x into derivative of log x is 1 by x. So which is equal to cos of log x into cos of log x by x. Hope it is clear. So this is how we do the chain rule. One more example, let us see. d by dt of e to the power of t. Suppose I have. See, I have a formula for, if I have d by dx of e power x is e power x. d by dt of e power t is e power t. We have the formula. But in place of t, what do you have? You don't have just a t, you have 2t. So that is again a function. So how do you differentiate now? First d by dt of e power t, 2t is e power exponential function as it is, e power 2t into, what do you have here? 2t, d by dt of 2t you have to do. Again differentiate that also. So this is d by e power 2t into, then again this 2 is a constant, bring it out, into d by dt of t. So which is equal to e power 2t into 2 into derivative of t. d by dt of t is 1. So this is equal to 2 into e power 2t. Right. Now let us go for the one more example of the same model. Y is equal to tan of x square minus 6x. So again here y is tan u, and where u is x square minus 6x. So what is the formula? dy by dx. Y is to u and u is to x. You want dy by dx. Y is tan u and tan u is x square minus 6x. Tan u is x square minus 6s. You want to go from y to x. So dy by dx, dy by du into du by dx, dy by du with respect to u first and then with respect to x. So what is the first one? Dy by du means d by du of tan u into du by dx means d by dx of x square minus 6x. So what is derivative of tan is secant square u into, now d by dx of x square minus 6x, the first formula if you apply, x square derivative is 2x, 2 into x to the power of 2 minus 1. Hope you understood this, right? So this is 2x minus, then 6 into, your 6x derivative is 6 into derivative of x is 1. So 2x minus 6. That is equal to secant square of, in place of you substitute the given value, that is x square minus 6x, x square minus 6x into 2x minus 6 into 1 is 6. So 2x minus 6, which is equal to 2x minus 6 into secant square of x square minus 6x. In the next coming lesson, we will work out problems with using all together all the formulas what you have learned till now. Thank you.